A while ago, while watching a certain superhero movie, I noticed a certain superhero who used magnets to put on his high-tech weaponized suit. I was very intrigued by this and wondered how one could make magnets stronger. And not with the state-of-the-art government research facility, but at home for cheap. I finally decided a testable variable would be temperature, so I asked myself, what effect does the temperature of a magnet have on its strength? And so my Google Science Fair journey had begun. I began to research and soon found that esteemed scientist Pierre Curie had written a doctoral thesis on this very topic. I researched various sources and hypothesized that if the temperature of a magnet is increased, the magnet will become weaker. To test the magnets at various temperatures, I used a freezer, an ice bucket, and a pot of boiling water to bring the magnet to negative 15 degrees Celsius, 0 degrees Celsius, and 100 degrees Celsius, respectively. I also tested the magnet at room temperature. After bringing the magnet to the desired temperature, I tested its strength by lowering it onto a plate of paper clips. I then carefully picked up the magnet and counted how many paper clips it had picked up. My data followed the general trend I predicted. A few paper clips were lost from one temperature to the next, except for the strange spike at room temperature, which could have been my mistake while placing the magnet on the paper clips. But in general, as the temperature increased, the magnet's strength decreased. This is because when cool, magnetic domains, or particles within the magnet that act as little magnets, move very little, so they line up and create a strong magnetic field together. When the temperature, which is the speed of the particles by definition, increases, the particles become less orderly and they don't line up as well, and the magnet becomes weaker. My final conclusion is, as the temperature of a magnet increases, its strength decreases.